It's not needed to understand all the level of detail of the sub-functions, but we can continue with running our model. We see that this part is finished, as we see number 5 here. And the next part, unfortunately, cannot be run just as a script, but we need to run these commands in a command line, basically using CLI. So we can copy one by one these into a command line prompt. So I'm going to open again an Anaconda prompt. Activate my environment. And here I can simply just paste this. And in this case, it's running the water module for specific use of the template model and for a specific scenario, which is called MLED baseline. It's going to take some minutes, so we let it run unless we notice some errors. So when a scenario is finished, you will see this type of message that message run has been solved and the status is normal completion. It means that this scenario was successful. This was the baseline Nexus. And so you can continue with the other two. And they need to be done one by one. The improve and the ambitious, and then we can go back to the script. Okay, once these 3 scenarios have been run, you can continue with running the scripts. In case you have closed the Jupyter notebook and you're opening a new one, you need to at least rerun the first 2 steps in which you load the packages and you define model names and open the platform. Otherwise, you can just continue from here. We run this block and the final block, which adds basically irrigation to the model that has and now also water infrastructure implemented. And now I'm gonna wait that this block is solved. So basically opening again the local modeling platform, although it has been already open, but in case you are rerunning the script, and then we launch this part. When this last part of the script is working, we see some feedback, and basically it is cloning the scenario into the last scenarios we have, which is called Nexus full, and is also basically calling the water crop functions and solving the model, setting it as default, and finally running reporting, which means it generates some Excel files with output variables. This will also take some time, probably about 20 minutes or something like that. So in the meantime, I'll show you where you can look at your outputs. So while this script is running, we look at some output locations. There are 2 different outputs. One is exactly the GAMS files outputs, and also input data, and others are basically readable output in an Excel format. We start with the GAMS files, which are located usually in a folder within your Anaconda library in the environment that you have been using within site packages within the MESSAGEix package. And there you probably have a folder, the MESSAGEix folder, in which there is a model folder, and here there is the core message code if you want to look at it. And there are input data that are generated when we run GAMS, and there is output of the model. You can open it using GAMS Studio. Actually, I think it's very good for learning to open one of these GDX. You just drag it in, and you can explore the different variables and parameters. For instance, capacity is a variable that says it's the output variable of the capacity, which is representing the installed capacity of technologies. And here we are looking at the level. We can see which technologies are installed in which time period and in which region. You can filter and look at many other characteristics. For instance, investment costs. You see these are inputs, this is parameter for different basins or for the whole country. What are the assumption used or the input investment cost in the model? Okay, once our run are finished, and so basically if we don't get any errors here, we can actually check the final results, which are the reporting outputs, Excel files, which are contained in the MESSAGEix model folder under reporting outputs. You can see different files, 3 for each scenario, because the reporting is basically running a reporting for the energy part, a reporting for the water part, and this called LIPRI is at the end the reporting that merges all the outputs. We can open one of them, for instance, for the ambitious scenario. And here you will see the model and scenario. In this case, is just one. And there are different regions, the basins of Zambia, or the whole country, and different variables. For instance, we can look at, for instance, a simple variable, capacity addition of water infrastructure. We see these are very aggregated variables, but we can see in terms of cubic kilometer for the country or different basins how much capacity has been installed. You can look into detail into different variables, and this is basically the files that is used and plugged into the LIPRI Explorer, and or also used to make figures for papers. And in particular, the script for the figures are located in this folder. Is the R script, where in outputs you can put the model outputs you obtain, and you can run this script called figures, and you will obtain different figures. Here's just some of them. Basically, are figures that can be used in reports or papers. Here we open R, and by opening the figure script, you can run through it. And in case you have another country, you can also change the country name and the delineation file. And this will generate different output variables. As I also pointed out in installation presentation, here is information for Ascan support. Don't hesitate to, first of all, look at details of MESSAGEix. It takes usually a lot of time to learn how it works. And also, if you have specific questions related to this project, please contact me by email. And probably before going to the next part of the presentation, so implementing Nest or the MESSAGEix Nexus for a new country, make sure you have a good knowledge of the model and how is it working. This is the implementation section. This is the last section of this presentation, and we talk about how to replicate MESSAGEix Nexus for another country. It's not going to be a full case study because I haven't completed the process. It's a long process, but these are hints and suggestions for people who want to do it. How does it work? One reason why I cannot go through the whole process is that part of the process, especially the first step of building a MESSAGEix downscale country model, is based on non-open source tools yet, or like especially they have not been published yet. They've been developed at IIASA. It's a tool that downscales from the global message model to a country while giving pretty detailed also assumptions and specifications and extracting energy balance data from IEA data, which are unfortunately not open source. Here is a link to a private repository that contains the code and data for a specific country to do this process. If you're interested, please contact me by email, vink@iasa.acat, and I will try to get you access to it, and then you can start using these tools to develop an initial country level MESSAGEix model with only energy. and one single node country. Now, very important, we are going to look at some data. In the first part, the previous section, I haven't talked about data so much, especially the raw data, but I show you that there are several R scripts in the RE4AFAGRi GitHub repository that actually draw data from somewhere else, which was not included in the GitHub repository for space reasons, but these raw data are contained in the Zenodo repository called nestapplication.zip. You can download that and place that folder of the Nest replication inside the GitHub folder you already have, RE4AFAGRi platform /next/data. As I said, this would be the raw data, which is processed by the R script contained in the folder under project librenest data, while the outputs of the R scripts are basically the post-processed data used in Nest in the model directly, which are included in the data folder under MESSAGEix models and the project librenest, and also some in the water folder. So while for the previous part to just rerun what we did for Zambia, you just needed this post-process data. In case you want to change country, you need to basically go through the pre-processing or raw data and make sure you have similar data in your database. And you also look at the R scripts and make sure they're compatible with the data you're proposing. We're not sharing basically all the possible raw data for all countries, although many of those are global. Here is a screenshot of the raw data folder from the Zenodo repository. You see all the raw data that is used for the Zambia model. There is crops, data from water crop, data for energy calibration, related to food, hydrology, data coming from the other models, MLED and onset. If those exact data are not available from those models, one can simply understand what is the data about and replicate it, also coming from other sources. That's fine. And then there is the Zambia Nest delineation, which is also defining the geographical shape file of your case study. Here I would like to clarify a little bit about the data folders, the raw data, and the post-processed data, and the scripts, because I know this might be confusing. So I have downloaded the Nest replication from the Zenodo link, and I suggest you copy this folder containing the Zambia data, raw data, that is only needed if you want to generate a new model instance. I copy it into a Nest folder, and I make a folder called data. And then we will make sure that the R scripts that we need that process some raw data will be linked to this folder. Then on this side, I'm also opening the Nest folder, and I want to show where, for instance, data related to the water module is. In this case, it's not raw data, it's the post-processed data are under water, and these outputs are generated basically by the scripts that are under model water data file. So these pre-processing scripts take raw data and generate this data that are used by the model, post-processed data, while these scripts are Python scripts that are used to build the model. Similarly, if we go back here and we open projects, librenest, these are post-processed data, input data for the GAMS model, which are generated by the scripts within the Libri project data. So these R scripts take the raw data I showed you before and output these model data files, and the other scripts, as you saw already, are just functions that build up the model. This screenshot shows exactly which are the R scripts that on one side in the watcher module, on the other side in the Libri nest module, so project specific, where there might be dependencies on the countries. You should open those and see whether there is a country name, whether they just process like global data. Here is an example of one of these processing scripts in R, where we can change simply small parts of the code and basically use it for other countries, especially when this data source is for the whole continent or global. This case is a case of grid data processing from the onset model, in which we actually receive outputs for the whole sub-Saharan African region, and we basically crop the data results with the spatial delineation of Zambia, and just by replacing the delineation file and also the country name here, you basically be able to use the same script to the same purpose, just on another specific geographical location. Especially concerning the shapefile, here is an example of what I did to generate the Zambia, basically special units, but any user can define a region differently. In particular, I downloaded a hydroshed basin level 4 that defines hydrological basins or sub-basins of the whole continent of Africa, and I downloaded the administrative boundaries of Zambia at the level 2, and I crossed them using a software R, but you can also use GIS software to do that. And then the results was basically the shapefile with which I checked the name of the regions.